Monitoring tool. Why monitoring is required? I would like to say that database monitoring is a crucial part of any application or database maintenance. Finding database issues on time can help the application remains healthy and accessible. Without solid monitoring in place, database issues can go unnoticed until it's too late and cause outage. This kind of outage can cause losing money and customers as well. Like any operational monitoring, database can be proactively or reactively monitored. While proactive monitoring approach is favored by most of the people, there are plenty of monitoring tools like AppDynamics, POA, Badger, Postgres Enterprise Manager, SolarWinds. Some of are subscription based and some of are open source. So now I'm going to show you the demonstration on how Postgres Enterprise Manager set up on hybrid infrastructure I have implemented. In this demonstration, I'm going to use CentOS 764-bit as OS for my database server. My database server is on premises and monitoring tool PEM installed on AWS Cloud EC2 machine. That particular EC2 also have CentOS 764-bit as operating system, and I'm going to access my PEM via web client from my laptop. This is my implemented setup which I have done. As you can see that my PEM server is installed on AWS EC2 and PEM agent is installed on my on-premises database server. I can access PEM and monitor my all the databases via PEM web console from my laptop. Let's see in this demo. This is my AWS machine where I have installed PEM server, and this is and you can see that here I have installed all the PEM. My PEM services are up and running. This is my on-premises database server, and you can see that over there EPAS 12 is successfully installed and services are up and running. Now let me connect to the PEM web console. This is the login page, and after the successfully login, this is the global overview dashboard. Here you can see that my agent information about my on-premises database server, which is Patroni HA proxy. So I'm click on this. Here you can see that all this particular dashboard is for the operating system monitoring. So you can see OS overviews for CPU utilization, storage, memory utilization, and file system utilization as well. When you click on this and goes to the on-prem, my database server, here you can see there is the information about all the databases related to that. Demo, EDB, Postgres, test. And if I want to go to the particular database, let me click on my test database. You can see the information about my test database. This is the test PITR1 table. So as you can see that all the dashboards and all the monitoring data are completely accessible for my on-premises database server. Now let's move to the next tool, backup tool. Why backup is important? Backup helps the DBA to restore the database during the disaster or restore data after data files are damaged or deleted. So we can say that database backups are essential for protection against the unexpected data loss that can completely interrupt or stop the business operations. There are several backup and recovery tools are available in market. Among them, again, some of like Barman, PG-based backup, PG backrest, BART. Again, some of the tools are open sourced and some of are subscription based. So in this demonstration, I'm going to show you the how the BART can be set up and can able to take the backup and restore on hybrid infrastructure. In this demonstration, I'm going to use CentOS 7 64-bit as operating system for my database server, which is on-premises. And I'm already installed my BART tool on AWS Cloud EC2 machine. That EC2 have CentOS 7 64-bit as operating system. So this is my implemented setup. As you can see that my BART is already installed on the AWS EC2 machine and my database is on-premises. So I'm going to connect to the BART server via PuTTY and execute the command to take a backup of my on-premise databases. So let's see in the demo. So this is my BART server on AWS EC2 machine. You can see that BART services, the process for the BART are successfully running. And this is my database server, which is running on on-premises. Over there, I have installed EPAS 12 successfully, and all services are up and running. So let me connect to my EC2 machine and try to take a backup. So this is the full backup command for BART. So now you can see that backup job is successfully initiated and now backup process is started. So let's wait to complete it successfully. Now it is completed successfully. So you can see that backup start time, backup end time, and total duration is 8 seconds only. So it is quite fast. So let me show you whether this is my backup name. So let's see whether it is showing or not. So there's a show backup command for the BART. You can see that this is the latest backup. It is successfully taken. So here I would like to highlight that please note that when you have tried to install BART on a server, please make sure that you have enough amount of RAM on the server. Otherwise, very high chance of backup fail due to out of memory issue. Now let's move to the next tool. High availability tools. Why we need that? For many of the customers, high availability is a key interest. Their architect spends a lot of time in designing and planning for high availability of applications and databases. HA is important for business continuity. A short downtime can lead to loss of business. Therefore, this particular topic needs to be addressed effectively. There are many tools are available in market for HA, like Rep Manager, Patroni, Enterprise DB Failover Manager, and many more. As we know very well aware about that, as we know that some of the tools are completely open source and some of the tools are based on a subscription. So here, now I'm going to show you the demonstration for EFM setup on two kind of infrastructures. Number one, where virtual IP is not possible to get on a popular cloud vendors like AWS, Azure, and Google Cloud. Another number two, where virtual IP is possible to get on a cloud vendor like DigitalOcean. So throughout in this demonstration, my entire servers, all the database servers and EFM installed EFM and services completely running on DigitalOcean, and I'm going to use CentOS 7 as my operating system. So this is the setup of EFM on AWS, where virtual IP is not possible to get and assign to primary or master node. So I have used AWS Elastic Load Balancer, which will be balance the load after the automatic failover performed by EFM. So it will balance the load between the uh, master and standby during the event of the automatic failover. I have written and attached for the load balancing operation I would say I have written the uh, written and attached the fencing script with the EFM. So this is my fencing script for primary and secondary. These scripts will register the active master node in ELB and deregister the failed node in the event of the auto failover. This is the setup of EFM on DigitalOcean, where virtual IP is possible to get on the VMs. For the virtual IP assignment from master to standby in the event of auto failover, I have written and attached the fencing script with EFM. And this is my fencing script for primary and secondary. These scripts will assign the virtual IP to the active or master node in the event of auto failover. So now let's see in the these things in the demonstration. So first of all, I would like to show you the console of DigitalOcean and the details about my EFM primary machine. So this is the public IP address, private IP address, and this is the virtual IP, which is going to be float between EFM primary and EFM secondary machine. So this is my EFM secondary, and this is the IP address of my EFM secondary. So now this is my EFM primary server. This is my EFM secondary, and this is the EFM witness server. So now let's see my replication services and EFM services. So here you can see that this is the primary server running on this IP address, and my server is running on this IP address, and both servers are in sync, up to date, and it is safe to promote. So now I'm going to connect to my secondary, and I'm going to perform the controlled switchover. So it is done. Let's see the status one more time. Now you can see that my standby machine become a primary server, and primary server become standby machine. So switchover is successfully done. Now you can see that EFM secondary got this virtual IP. Now you can see if I go to the EFM primary machine, this machine there is no floating IP address over there. It is assigned to the newly promoted server, which is EFM secondary. See, and let me try to connect my FNL. I'm connect right now. I'm going to connect that. See, now it is able to connect, and it is going to be a secondary machine. This is my secondary, and I'm going to connect that. See, newly created database demo is there, and it is also successfully replicated. in this rod as well. See, it's also there. So now you can see that how it is possible to deploy the EFM tool, where very easy to deploy this EFM tool where the virtual IP is possible and assigned to your infrastructure. And it is also possible to assign, if it is also possible to use the EFM with where, on a popular cloud with the appropriate load balancer as well. So that's it from my end. Thank you, everyone.